So let's talk about residential concrete construction. So this video or this PowerPoint is still kind of being put together, but this is kind of the best I have for right now. Let's talk about a little history about residential concrete. Residential concrete was really a lot of, we've all lived, if you look at history of mankind, we've all lived different ways throughout time. And probably one of the biggest modern day residential concrete changes has been through Levitt and Sons, whenever they really created what you think of now as suburbs and residential homes and custom homes and stuff like that. So before World War II, when they came in to build houses, a lot more of the time they were just custom built homes, and you may have a contractor that comes in and just builds the entire home by himself, and he may be great at doing the the walls or maybe the bricks, but he may not be great at other parts like the windows and doors, or you fill in the blank. But they had to kind of be a jack of all trades. And so now Levitt and Sons, they came in, they realized that, hey, it's World War II just occurred. People, all these soldiers are coming back. They're wanting to have, there's this big baby boom that's starting, and people need houses, in a huge way. Well, luckily for them, they had about 6,000 acres in between Philadelphia and New York City. And they said, hey, let's go ahead and develop this land and figure out how to build houses like crazy and help these people out, and it helps us out, and life's great. And so one of the guys was really smart. He goes, let's go ahead and think about Henry Ford and this assembly line and how he revolutionized how we do vehicles and transportation stuff. Let's go ahead and take that same assembly line, and maybe we could do that in home building. So that's kind of how tract houses kind of got started. Was we kind of take this assembly line approach, and we develop, we design our houses in a certain cookie cutter type way. We have our construction management team out there. We have a lot of different subcontractors come out and do all the work, but they're really skilled in their specific area. And then you buy a lot of your materials in bulk. So that's kind of the picture of the cookie cutter houses. It's really cool. There's some books and a lot of good things online where you can find a lot of these pictures like I did. But this is kind of, what you think of as a standard cookie cutter house. And eventually, building the same house over and over again, they realized, hey, Joe over here and John, they it's hard for them to tell which house is theirs. If there's 10 houses on this block and they all look the same. So let's do things like, not only changing the paint color, but maybe just changing up some of the rooms where they're arranged at, stuff like that. And, and kind of give maybe a couple more options. And so that's exactly what they did. They started coming out with different floor layouts. And what was really awesome was these contractors would come out. It'd be like, say, like an 800 square foot house, 1,200 square foot house. And they knew exactly all the materials that you need. Levitt and Sons would know all the materials that you would need for that subcontractor. And so they'd come in and they would just have a team of professionals come in and build these houses. Sometimes these houses were done within a day. That's right, a day. So it was really crazy watching these people all come together like an army, an organized army, and build all these, build a home so quickly. And they had the floor slab you can see down there. So they even knew when they did all their estimating for their construction materials, they even knew down to the right brick how much that would cost and everything. So it was really cool how it was all done. And so you can just kind of see here, here's the aerial view of, of the houses and what they kind of look like after they built a bunch of them. And so when we talk about the concrete part of just residential concrete in general, you really have two options. You either, you know, usually have a concrete floor and the foundation in the garage, and that may be all poured, you know, it's usually all poured together. And then you may also pour the driveway and sidewalks, and then, you know, front and back porches, and then the AC, you know, pads and anything like that. You may go and do all that at once. Or, and that's kind of what you see with option two, you may have another option, which is, you know, you kind of wait after you do your foundation and floor slab in the garage. You may wait, you come back after the driveway and sidewalk and porches. You know, you can kind of give a time in there so that people can come, so that the other contractors can kind of come by. They can build everything they need to build, and that way they're not making the concrete really dirty, and you don't have to come back and power wash it and stuff like that. So a lot of people prefer maybe one method over the other. I'm not going to get necessarily into both methods. I'm just saying there's lots of different concrete practices and construction practices out there that people prefer one over the other. And so I'm just telling you the options. So typically whenever you talk about a floor slab, we're going to go through, you know, just kind of the basic process and some of the ins and outs of residential construction. So the first part is you want your, you know, your ground, your dirt work, you want that done. You remove all the vegetation, remove any soft soil, stuff like that. And then you want to, you know, always build build on a solid foundation. So another thing I should probably mention is that you want these pads, these slabs, to be higher than some of the low points around there at least. Okay, see houses that are built a lot of times that are 2, 3, 4, 5 feet lower than any point in their entire yard, and it's crazy because they go, I don't understand why it's flooding, and it's like, well, water flows downhill, and downhill is your entire house. So instead of, you know, build it higher than you know, build it higher than you know than that. It's kind of basic. You know, you think that'd be pretty basic for some people, but kind of sometimes they don't realize, oh yeah, we don't want it just flat, or you want it higher. Sometimes it's the road, you want it higher than the road, you have a ditch in the middle. But you know, I mean, again, it just depends on what your conditions are, what your site conditions are, and where everything's draining to. So make sure you have a nice, you know, usually people call these pads, you have everything nice and level. You know, floor slabs are going to, you know, typically be pretty level. And then you can go in, you can dig your foundation like you can see here. It's very common in Oklahoma, especially, to do strip footing and to move your rebar and have a big enough space where you move your rebar over here to connect the slab and the foundation together. Then you have your formwork right on top of that foundation. And then once you build your concrete formwork and you pour your concrete and everything like that, you come back when you remove all your formwork. You can come back. Eventually, those brick masons will come and start laying brick right on top of that foundation. So it provides a foundation for them, provides a foundation for the slab. Everybody's happy. So that's kind of one of the designs that they'll use, very common for floor slabs. You can kind of see here, this is maybe a 2 by 8, 2 by 10, something like that. And then you have, every so often, you have these bracing forms, these little triangles, little right triangles, where you will come in and maybe you can put, you know, this 1 by 4 and this 2 by 4 together. into an L shape. You can pop it down right there and put in, make sure it's a square, or it's good on bottom, make sure the form's all nice and level. It's kind of where you want it at, and put a couple nails or a couple screws into the foundation, and then a couple into the forms. And then you have this hypotenuse right here, and you can make sure everything's going to be nice and level, straight up and down. You can kind of push this piece up and down with everything. And you want to put at least 2 nails on the top, 2 nails on the bottom, and that'll kind of secure everything really well. And so again, your floor slab thickness, that can depend on all sorts of different things. Your foundation, what that looks like. Obviously, if you're doing a basement and you want a basement on your house, or that's going to obviously look a lot different. You're going to have a lot higher walls and everything. It's not uncommon if you have kind of out of level floor or pad to begin with. It's not uncommon to go in and come back with the edges being higher on certain sides and lower on the other. So just kind of recognize some of that whenever you're doing it. Also, your aggregate base and your thickness of your slab can also play dearly into how thick you need to pour that slab. Oh, I don't know how this got in there. This is a picture of a rare photo of a tree that Home Depot and Lowe's get their lumber from. It's not true. I have no clue where it came from, but sometimes people get real picky when they do form work, and it has nothing. Clearly, people go through and pick out the good lumber, and so if you've ever been left with the kind of the not so great wood, you kind of get mad. So but obviously Home Depot and Lowe's are great places, but there's clearly some people out there that have kind of been the short end of the stick, where they don't have the good lumber. So but whenever they came there, but I've been there when they've had excellent lumber. I've used it. It's been great sources. So I'm not saying anything bad about Home Depot or Lowe's. I've used them both and been very happy with them. But so kind of moving on, when we talk about placing subgrade, and usually have your plumber and your electrician come in, and so they may want you to do all the dirt work beforehand, so they kind of know where grade's at. A lot of times they want to come in and they don't want to mess up all your subgrade dirt work and aggregate base that you've been doing. So they say, hey, let me come in before, put a couple, maybe they put some pipes into the foundation whenever you guys are pouring it. And so now they're going to dig underneath that, dig towards that, dig all their plumbing, where their toilets and sinks and showers and everything go. And so they'll do all that then you can finish up the dirt work after that. So there can be a lot of plumbing in residential houses and a lot of electrical work and stuff. So you just kind of have to recognize that. And there's sometimes a battle between the subcontractors, because they can get kind of heated whenever you're really messing up some of the concrete guys' work, or maybe the concrete guys not being very not helping it very much to get the plumber and the electrician to have all the to get the right elevations and stuff. So just kind of be aware, work as a team, have some soft skills, how to talk to people. When we talk about reinforcement of residential concrete, really most concrete is going to be 4 inches thick, 3,000 psi, and compressor strength. That's just kind of the basics. For floor slab, it's going to be non-air entrained concrete, and for slab on, for the sidewalks and driveways and everything else that's exposed to freestall resistance, you're probably going to have 5% air, a lot of times 6% air, something like that is pretty common for the majority of the United States. We talk about, we use reinforcement. Most of the time it's going to be for non-structural type functions. So, number 3 rebar, so 3/8 inch rebars on 3-foot centers is really to help minimize temperature and shrinkage cracking. So, you can use WWR, which is welded wire reinforcement, or fiber mesh, whatever you want to call it. You can also use fiber reinforcement. So little steel or plastic fibers is pretty common to use. So this is what number 3 rebar looks like on 3-foot centers. This is what welded wire reinforcement looks like. Again, it can come in sheets or bundles. I'll show you a picture here in a second. It's used a lot of times in thin slabs. It's great when it reduces the labor of tying and building all your reinforcement. Can really do a good job there. But it does have a bad reputation because people don't always know how to install the WWR very well. They just don't know how to install that wire. And so it has created some bad reputation. But I'm going to tell you, it can be really good stuff if you know how to use it and you can install it properly. If you don't know how to design it and you don't know how to install it, then, it's like anything. It's not going to be very good to use. But this has been very successful for at least 80 years that I know of. And so I highly recommend people to use WWR in sheets. So use the welded reinforcement mats. Those sheets work really well. They work. They minimize a lot of the problems that the concrete guy has and the design person has. The rolls are usually the thinner, not as big in diameter. Big in diameter, heavy duty type welded sheets. So you really want to make sure that you use sheets if you can. That's what I highly recommend, because those rolls can create waves throughout your concrete because it's hard to get them all nice and straight again. There's probably somebody out there that's really good at making them nice, flat, and straight. You're the unicorn, the one I've dealt with this stuff a lot. I've had my fingers crushed in the bundles a lot, and had them bleed and all sorts of stuff. I just like the sheets. I think they work a heck of a lot better, and people that use the sheets, are just seem like they're happier. They got bigger smiles on their face, from my experience. Maybe I'm wrong, and that's okay. But when we deal with welded wire reinforcement, we can talk about the overall width and the length and the transverse width and the longitudinal width and kind of what that's all about. And so there's kind of an example, probably the most common, WWR, a 6x8, which is a 6x8. So you have 8 inches in the transverse, 6 inches in the longitudinal. Which is also where they get the W8 by W4 is 0.8 inches of longitudinal wire by 0.4 inches of transverse wire. So just kind of be aware, that's kind of how they do kind of some of the naming. So if you have a nice sheet, this is kind of how they design things. If you have a nice sheet, then it can be placed pretty well. If you have it in rolls, like I said, it's kind of like a little wave throughout the concrete. Sometimes you got to cut that wire up. If you use plastic chairs, you don't have to pick up that wire. And it's recommended that you use plastic chairs or brick or something to hold that wire up, not just pull on it all the time. So just kind of be aware. So another thing that people kind of move towards in residential is they got tired of the rebar because there's a lot of installation cost, and it's not as, they wanted to work with something that was not only cheaper material wise, but but they didn't have the labor issues like with WWR, where sometimes people just put it in wrong. So what they said was, well, let's try this fiber stuff. So you have fiber reinforcement, these little bitty small little fibers that you can actually, come in bags. You can put them into the concrete ready mix drum, and you can just pour it out on the ground. And so some people still want to see that reinforcement, so they don't always like that idea. But fibers have been really good to minimize cracking. Especially the plastic ones do an awesome job for plastic shrinking cracks. Let's do, so a lot of times people talk about micro cracks and macro cracks depending on how long they are. So kind of be aware of that. They can also talk about the different shape that fiber is. Whether it's straight or it's deformed or it's crippled or paddled or hooked or whatever. They can also talk about what it's made out of. So the different materials that make these steel, whether, and so there's lots of different type fiber types out there and their diameters and the common range to proportion them. So just kind of, usually your steel is probably your most, common that came out. Sometimes they have steel balls in there where all the fiber kind of gets caught together. So people started using some type of plastic. So I see polypyrene is probably like one of the more common ones here lately that people started using more. I've seen some nylon and some glass fibers. But most of these I've seen being used at least once in the field. So just kind of be aware of that. The PVA is the same kind of, is a little bit, I think, newer if I remember right. And people have really latched onto that lately too. So whenever you have to come back for residential concrete, you need to place that concrete. Well, guess what? A lot of times you got to be real careful. When you're placing it, you don't want to pour if there's any pre-existing concrete like you see there, or maybe the actual, maybe it's a floor slab or the walls of the concrete. You want to make sure that you have something like you can see here, kind of protecting it from getting all wet, getting concrete stuck on it. So you want to pour it nice and slow whenever you're pouring the driveway and stuff around the house. We've talked quite a bit about when to place concrete and finish it and stuff like that. One of the things I should probably kind of mention, how you place your concrete. It's really important to realize you don't want to get cold joints. So this isn't the best picture in the world, but in essence, if you're pouring a bunch of concrete and your next load of concrete doesn't show up for a while, well, this is eventually going to get hard enough where it's going to start setting up. And if another load of concrete comes out, there's kind of like a point of no return where the concrete may not marriage back together and create one nice monolithic concrete slab. It may actually be two different slabs, and then there's just these ugly cracks that kind of come together. So kind of be aware you don't want cold joints. Also, when you deal with residential finishing, there's a lot of little details in residential compared to if you say things like if you look at them compared to residential finishers or compared to commercial finishers, especially ones that are like on highway jobs, there's a distinct difference between their abilities. And it's not that, one's necessarily better than the other. It's just a little different. So you have to be aware that they're maybe used to doing, a lot more hand type finishes with residential. But when you go over to commercial, there's a lot more machine and stuff that's being used. So they can do a lot more bulk. But these residential guys are a lot more focused on what I would call, they should be more focused on the quality and the low volume that they're using. And so a lot of residential, finishers have to make sure everything's kind of done right, because one little picky thing from a customer, and they have to replace a sidewalk and stuff. So they got to be really detailed. We talk about doing a floor slab. It's just like when we talked about commercial floor slabs. You go in and after you place it and level it, you do your initial finishing. A lot of times you'll just do a bull float, and then go back with a hand float and finish the edges where you couldn't get the bull float all the way. And then you wait for it to initially set up. And then if you have a pan float, you use a pan float. If not, use float blades or combination blades, and with a trowel machine, and you start getting the top surface hard. You don't really have to go and make it look like glass. You don't have to make it look super shiny, because a lot of times they're going to put carpet, they're going to put other things on top. So you don't necessarily have to get the nice glass finish that some people may expect you to have. So just kind of be aware they may want it actually a little fuzzy, so they can actually go out and put the tile and stuff down, and it will bond better. So be aware of that. Again, you have after floating and before floating, and how the major differences kind of look right there. And then you have your bull float. You have your bull float. Right here, you can kind of see there's step down, so there's multiple pads. And then this kind of comes in, and so you're actually floating the top of the concrete to get all the rocks down and make it nice and smooth on the surface. And these finishers are coming back behind and getting the edges where the bull float maybe leave a line or can't get as well. So when we talk about troweling, so the next step's troweling, like I said. You can use, float blades or combination blades. A lot of times you can start troweling that concrete, where whichever way you started doing your bull float or your straight edge, you want to go in the opposite direction. So if you bull floated this way, north and south, up and down, you want to go horizontal is going to be your first trowel passes. And then your second trowel pass would need to be the exact opposite of how you just trialed. And that way it gets a nice flat surface. There's no waves in the top of that concrete, so it's nice and flat. And you may want to do 3 or 4 passes, where your first pass maybe with a pan float, your second pass maybe with a combination, or even just a hard steel trowel finish. But you don't have to go 5, 6, 7, 8 times with a hard trowel. You just got to be kind of careful. So when we talk about walk behind trowel, these are kind of this is a picture I found. Kind of talks about the different spot or different places within a walk behind trowel. Most of the time they're either 36, 42, 48 inches is kind of what the blade space, the diameter of a walk behind trowel machine. So this is my grandpa finishing, I think it's a mini storage, but it'll be close enough for what we're doing today. And so he's just out there, having fun, just finishing the top of the floor slab. It's pretty easy to, if you've ran it, a few times in your life, it's kind of like riding a bike. It don't matter how many times you troweled concrete, you can do it pretty easy. And so, you kind of have to, with your hands, got to realize which, which way the blades are spinning, and you can, with your hands, you can kind of do opposite, picking up and moving and stuff to get the finish, to get that machine moving back and forth. It's pretty easy once you kind of get the hang of it. I won't get into too much of that because some of the people I'm talking to aren't really finishers, and I don't want to necessarily, spend a lot of time talking about, hand placement and everything. So some people don't even use walk behinds; they just do riders now. So This is, you know, you can see here, this floor slab, they actually used instead of, you know, they not only used a walk behind trowel machine, but they have the old school before there were trowel machines, they had sliders. So they have two pairs of sliders here where they get on top of that concrete and they will finish the top of that concrete, you know, and fan it out, just like how a riding trowel machine would look. So you need to make sure when you have plumbing and stuff to really get around that plumbing, anything that's sticking out. You gotta be careful though when you're baptizing, whenever you're sprinkling water all over that concrete surface, because you want to make that concrete nice and smooth on the edges or on the top or anything like that. Because there's a lot of times people just start sprinkling a lot of water everywhere, and you know, guess what happens? All that water comes out, and it looks absolutely horrible on top. So there's a bunch of watermarks everywhere, and it actually messes up the durability because you have the white spots or high concentrations of water. So if high amounts of the water cement ratio is really high, and then the darker spots have a much lower water cement ratio. So it may be 0.7 water cement ratio of the really light spots, and then the darker spots may be more like a 0.53, stuff like that. So it's just not good for the top surface. It doesn't look very pretty. But a lot of times if you're not, you know, that if this isn't being exposed, the floor, you know, might be just fine if you're going to put carpet or tile or something on top. That garage floor, though, I guarantee you, people are not happy with it. So this is the garage. You can go through and actually put in your garage door. So your garage door, you want to have a broom finish and have a little step here so that, you know, a little bit of a step down or whatever, slight one you normally, so that, you know, your car can still get up in there. Sometimes people want it more like a commercial door, and they may have an 1.5-inch drop. A lot of floors, though, for the residential, they may not have, you know, it's just a very, very, very small drop down, just to kind of create a lip so that it can seal better. But it's all nice and flat right there. So kind of how one way to do that, if it's just, you know, one door, then you may want to take a little 2x4. You kind of measure, make sure you have it wide enough. You take a shovel and remove all the concrete that you need. Then you come back in and you hand float it. Use a sponge float if you need to. Edge the bottom. Kind of like you see here, this is a 1.5-foot drop, but it's the same kind of, you know, same techniques. Here's a sponge float, there's an actual float, and you just want to make it nice and smooth, and then you want to broom the top of the concrete. So this is how you can see after they finish the concrete, they haven't sawed it yet. This is actually for a post-tension floor slab, so they may not actually saw it. But a lot of times if you do, they'll come in either the next day or after a few hours after they finished it. They'll come in and saw it. But you can see here the top of that floor is kind of fuzzy still. And that's kind of, you know, they don't have to be perfectly hard trowel finished. This is actually really good. You know, you don't have to make it look like glass. There's another floor slab that's after they pretty much just got done with it. They will come back in and they will actually trowel or saw the concrete every so often. You know, we've talked about when to saw it and how to saw joints. And obviously, if you're hand joining it, it's going to look a little different. You say for a sidewalk is every 5 or 6 feet, as opposed to you know, a floor slab sawing it with an early entry saw. It may be every, you know, 8, 10, 12, 15. I've even seen some specs that go up to 20 feet. So, you know, the goal is you want to make sure whatever you do, concrete likes to crack in squares. So just be aware of that. Make sure you're within your finishing window, that it's not too, so you don't have raveling issues, or, if you saw it way too late, you're going to get drying shrinkage cracks that go through your saw joint. So you want to make sure it's nice, clean, nice, clean saw joint here. So you need to be within that sawing window. We talk about the strength first time. And then obviously, whenever we talk about curing, it's kind of residential work may not even cure the top of the concrete, but there are ways to cure that concrete, especially if it's really hot or really cold. You need to make sure that, if it's really cold, you're going to have blankets, wet, have plastic, sheet or stuff like that, carrying blanket. If it's really hot in the summer, you're probably going to go through and put down wet burlap or curing compound or something, fog it, do something. So we talk about sidewalks and driveways. So after they build their house, they may come back in and do the sidewalk and the driveways. Again, this is all 4-inch thick concrete. This is where a lot of times you may or may not have, you may have reinforcement still, you may have welded wire reinforcement, you may just have fibers. So just kind of be aware. You see the little stakes, that's actually for the level, to make sure that it's going to be level throughout the entire, the grade, I should say, not level. The grade's going to be where they want it to be throughout the, for the thickness of that concrete. So whenever you sidewalk finish, for what we're talking about, driveway or sidewalk or porch or anything, typically these are the basic steps you're going to do to finish that sidewalk or that concrete. So you're going to do the basic placement, usually with a come along. You're going to strike it off, maybe with a 2x4 to strike it off. And then you're going to float it. You might use a bull float. You might just hand float everything. Then you're going to come back and you're going to edge and join it after it hits an initial set, and it can actually hold a joint or hold the actual edge enough where it's not going to create a bunch of waves and stuff. And then you may come back and you may do a very, very, very light hand trial, or use a Fresno or something like that to just remove any little lines and blemishes. You do not want a hard trial for air and trained concrete. Okay, so if you have a sidewalk, you don't want to take a walk behind or a riding trowel machine and just really work the top of that concrete. You're not doing it any good. You're not making it any flatter. Trust me, you're just not. So please don't do that. So this is kind of what, then you're going to do your broom finish. You use a commercial broom. This is what it looks like floating after and before. This is what a bull float looks like. This is edging the sides. You're going to have a little curve, or you may have a joint. So sawing the concrete, you may want to join it when it's still fresh to create that control joint. So there's lots of different types of edgers out there that you can use to create, how big of a curve you want on the side, especially curb and gutters. You can get some really well-shaped curves out there. So just kind of be aware. If you go to joining, there's lots of different joint patterns. You can see here, there's 3 different joints, types of joints. Curve, you can have like a V, or kind of like a V, kind of like a trapezoid or whatever in there if you want. You can also have it where there's multiple different, there's not just one joint, but there's multiple joints within that tool. So just kind of be aware of that too. A lot of times this will be used, this D, E, and F is going to be used to create a little bit more friction for ADD compliance, stuff like that. So this is, you can see my uncle's actually hand joining here of a sidewalk in a little town in Missouri for a city street city sidewalk. Again, we talked about blistering and how bad it is. You do not want to finish air and train concrete. Please don't do it. Please don't. Air and train concrete should not be hard trialed. Don't do it. You don't want to create this dense, thick layer on top that has air bubbles right on below. That it just creates problems. It creates a blister, kind of like on your hand. That blister pops, and you just have a void on that surface. It looks ugly, especially when it's everywhere. So please don't do it. Know how to finish concrete, okay? And we talked about brooming and tining. Tining is usually for if you're going to be having driving applications where you need not as much friction, but you need the friction to stay over years of time. You use tining if you use a broom finish for light foot traffic. That works really well. It's a commercial broom that kind of looks like that. So with that, have a great day.